You've got to try. You don't win things unless you try. So what are the criteria? So imagine you're writing this research grant application. You've got to show what you're doing is high risk, high reward, and that it's feasible. And then these criteria, and you got to. So I begin by saying, is it really important what we're doing? This is something that's really interesting. Top 5 risks to our planet from the World Economic Forum that meets in Davos. Look what's happened since 2012 to 2020. Environment are all the key issues that are the focus of the people that fear our planet's at risk. Biodiversity loss made it onto the list for the first time in 2020. So it's now recognized a global problem. This goes to show how unwise we are as a species, though I'm pretty sure that this would be different if they petition the same people today. I have a feeling that coronavirus and diseases might be somewhere near the top of that list. So, novelty, we're automating species discovery. We're bringing new technology to bear. The new bin approach, species interactions, new science, driven by multi-amplicons, only possible because of new technology. Global surveillance, only possible because of metabarcoding, and only affordable because of platforms like Novelty that weren't there 2 or 3 years ago. So that's the novelty side of things. Expertise, I built a team of about 60 co-principal investigators, co-applicants, and collaborators scattered across the planet. I think we'll probably do quite well on that axis because I don't think other people will be able to bring as much internationality to it as us. They want applications to build on world-leading approaches. And we are the world leaders in this field of science, and we've got a really unique constellation of people that work in this building. Nowhere else blends these different groups together in the way we do. And we've got a track record of running big projects and delivering on time and on budget. Cogency. You've got to demonstrate that your approach is the only one that can really deliver a solution. Well, morphology's got 250 years of showing that it can't scale. Satellites are great, but they can only track a few essential biodiversity variables. And barcodes scale, and they can track. And the other good thing is there's some reasonable basis to expect that we can raise the money. We've now got commitments of about $35 million from other nations. And if this Netherlands grant comes in that's in review, that'd bring us up to 60 million. So big investments being made, like 16 million from the European Research Council for a project that we're deeply involved in. So we're not going it alone. The work has, you've got to show now the high reward criteria is you've got to show it has some impacts. And I mean, I think this World Economic Forum statement is going to, when you're amongst the top 5 threats, that's useful. We've got a lot of buy-in from the major forces that are involved in monitoring global biodiversity, like the CBD, Convention on Biological Diversity. And I think the fact the Costa Rican government has actually said that we want this to occur and is actually putting money into it is quite helpful. The scientific goals and impacts, well, we launched in June in Norway, and our targets would really transform biodiversity science. There's no question about that. And we've also got strong links to both the Darwin Tree of Life project and the Earth Biogenome project that want to do the genomes of every species on the planet. So they need us to deliver the insights on how many different species there are. And so that's very good to see people in biodiversity science working together as opposed to trying to poison the waters for their competitors. We've got to show reward for Canada and the world. And in terms of Canada, this advanced environmental sustainability, intercepting invasive species, protecting agriculture, advanced uptake by government, NGOs, and the private sector, and they're also keen to see reputation. They want to see Canada leading global projects. So I think that will be helpful to us. The global impacts, we're going to transform biodiversity science with major impact on cognate fields, lay the foundation for global biosurveillance, and provide the information required to mitigate biodiversity loss. Criterion 3 is reach. You've got to show what you're doing is not something of interest to you and 3 of your friends. Our analytical facility here, CCDB, services about 300 people from around the world. Bold has more than 27,000 users and sees, oh, damn it, the IP address is completely wrong. It's 1.5 million IP addresses in 2019 visited Bold. And then impacts, bioscan isn't just about biodiversity science. It feeds ecology, evolution, taxonomy, and genomics. And the applications are diverse. Education, marketplace substitution, zoonotic diseases, and environmental assessment. Michelle was supposed to be giving today's talk. She's in Ghana, working on, with people, Gates Foundation-funded project called malaria something or other. Malaria what? Target malaria. Yes, get rid of malaria. It's got a lot of impact. The approach you're using potentially has wide approaches, and they need to understand the biodiversity in the region. Likelihood of realizing impact, the key elements are in place. So this is criterion 4. We've got the infrastructure, the informatics platforms, the research community. We've got a track record. And people like Graham, who know how to do artificial intelligence, stuff like that, the expanded dimensionality of the research team is really going to be key to achieving a lot of the goals in this next stage. Short-term benefits, well, species discovery, we're going to rocket past Linnaean pace, last 250 years, 6,000 per year. We're going to aim on 100,000 bins per year. And we're using new protocols that are going to turn these into species. Symbiome studies, as I talked about, are going to revolutionize our understanding of species interactions. Metabarcoding, the biodiversity baselines we need, and then the reduced costs are going to encourage societal uptake. The challenge, feasibility. Is it worth doing? And I'm not going to re-argue this point because I think it's absolutely easy to win this one, that what we're doing is critically needed by humanity. You need to build on current knowledge. You need to show you're building on current knowledge, and I think we can, again, do that without any major problem, that we've got proof of principle in all of these cases and proof of production for 2 of the 3, and this one's in progress. They want to see targets. They want detailed work plans. They want to know exactly how many things you're going to analyze, and I think, again, we have very good, tight targets. And then finally, the resource element. We've got the specimens, we have the sequencing facility, we've got the informatics platforms, and we have the research team. And that's all I had to say.